Welcome back, everybody. In this video we're going to be kicking off the beginning of our access connectivity, or what I like to refer to as the actual firewall section. And what we're going to be doing in this introductory video is walking through doing a lot of whiteboarding and laying a lot of foundation groundwork for how the firewall operates, how the access rules come into play, and doing, like I said, laying the groundwork for how all this stuff comes into play. So I'm going to go ahead and go away because I'm sure you don't want to look at me right now. And we're going to walk through a couple of different things out of the gate. So when we talk about how the ASA processes things, we have to understand what exactly the ASA is doing when it comes to traffic coming in to the device, how it's handled, stuff like that. Now, I'm going to go ahead and bust out my pen pad here for a bit because it's going to take us a little bit to walk through a lot of this type of stuff. So when we talk about the operations of the firewall and how it's going to process things and stuff like that, we have to understand what's actually happening with those processes and stuff like that. So when we talk about ASA 1 here, we've got a number of interfaces. We have the gig 0/2 here is basically applied for the VLAN 20, or sorry, VLAN 10 and VLAN 20 respectively. This guy here is for VLAN 30, which is the DMZ. And then we have the outside interface that's been applied and stuff like that. So these guys right here have a security level of 100. The DMZ has a security level of 50. And the outside interface has a security level of 0. Now, by default, the basic connectivity that the ASA has with no access rules in place, and what I mean by that is no access list permitting or denying traffic. The default traffic flow is from a high security level to a low security level is permitted by default. So this could be 100 to 99, this would be permitted. From a low to a high, whether this is a 99 to a 100, this is denied by default. Now, you might say, okay, well, what if I have interfaces that are in the same security level? Well, if they are in the same security level, if you have not already enabled the same security traffic permit inter-interface or intra-interface, that traffic will also be denied. Now, in a case where you have a firewall that is set up and you have the outside, you have the inside, and then you have a DMZ per se right here. Then you would have inside to DMZ would be permitted, inside to outside would be permitted, and then DMZ to outside would be permitted. However, actually, let me do this. Inside to outside would be permitted, inside to DMZ would be permitted, and DMZ to inside or to outside would be permitted. What would be denied would be DMZ to inside, outside to DMZ, or outside to inside. All of that would be denied because that's going from a higher security, or I'm sorry, a low security level to a high security level. Now you might say, okay, I get that, but how does it actually know? Well, it's actually a really good question, and that goes back to something that's been around for quite a long time called the Global ACL. Now, the Global ACL is an ACL that applies to any interface ingress. So if you take a look at any firewall, any interface traffic coming inbound on any of these interfaces is considered to be ingress. The traffic is coming in on the interface. Well, the Global ACL by default has a deny any logic. And the reason why it has a deny any logic is to make sure that if the traffic is going to be coming in on the interface, the security level alone does not interfere with that. So there's actually a behind the scenes mechanism, which is the Global ACL, that basically prevents traffic that's coming in on an interface from a low security level to go to a higher security level if the traffic was not already initiated from the high security level to the low security level. So there's going to be a connection table that's going to be built on the firewall when traffic from a high security level to a low security level is initiated in a high to low manner. Now, in that case here, then the traffic will be permitted to go outbound. And traffic that is permitted back through as long as it matches the connection table. So when the traffic comes back in on the outside interface as a reply or response traffic, the firewall is going to first look at the connection table and go, okay, do you have an existing connection? Now, we talked about this a little bit in a couple of videos ago where we were trying to get server 2 to be able to ping google.com, and it wasn't working. Well, we went in and we had to explicitly permit back in the ICMP unreachable and the ICMP time exceeded message values. Once we permitted those back in, and the reason why we had to do that is because when we were doing a trace route or a trace route or a ping or anything like that from a Windows box, it's sent outbound as UDP and it's received back in as ICMP. So this would not be in the connection table. This would not be a match. So therefore it is dropped because it's outgoing UDP receiving ICMP. Because that's the case, the firewall goes denied, which is what you'd expect it to do. So you need to explicitly allow that ICMP traffic back in, even though it wasn't originally sent out as ICMP, it needs to be received back in as ICMP. So that is the core driver for that. Now, because if there is no interface access rules applied on any interface inbound, then the Global ACL is there to help mitigate the traffic from the outside inbound from coming in. Now, the Global ACL is applied inbound on every interface, and it has a deny any logic, so it drops the traffic. That's why when you try to telnet into the box, try to connect from the outside to the inside, and there's no communication, then that's why. Now, you might say, okay, well, then why is the routing allowing it to happen? That's actually a really, really interesting scenario. And what's funny is when you try to go from a low to high, it's still dropped. So let me explain what I mean by that. So let's let me swap from my pen pad over back to my mouse. And let me go to, let's pull up this is our test server, server 2. And on the test server, we have a, I believe I have, let me go to, yes, I have remote desktop enabled, and I am 172.16.30.10. Now from my PC, now I'm on the outside network, I can ping the firewall, right? I can ping ASA1. But if I try to ping 172.16.30.10, it's going to get dropped. And you might say, well, why is it getting dropped? Well, the reason why it's getting dropped, and if we look at the real-time log viewer, we can see that it's right here at the bottom. It's in yellow. I don't know why they chose yellow, but you see deny ICMP source outside 10.255.10.7 destination DMZ VLAN 30 172.16.30, and it was dropped. That right there, ladies and gentlemen, is a classic example of the Global ACL kicking into play and saying you can't do that. Now, if I went to this guy here, and I went on to here and I typed in ping 10.255.10.7, I can ping my computer from the server, and that works just fine. But that's a high to level, or I'm sorry, high to low. Low to high is denied. Now, with that logic in place, you might say, okay, well, the routing is there. The routing actually has nothing to do with it. The routing is just there for reachability purposes from behind the ASA into the rest of the network. It's just supposed to get you to the ASA. The ASA is still going to have firewall rules that come into play to mitigate anything that might pop up there or might take it happen in that play. Now let's talk about how this comes into play when it comes to the other access rules that are available to us. So we have a couple other access rules that are available to us. Let me go ahead and clear the screen off real quick. So we have the Global ACL, which we already talked about. So I'll just put the GA is deny. Just keep that in the back of your mind until for a moment. Now, the Global ACL technically is processed second out of a potential 3-step process. So the very first one we have, first step in access rule processing, is the inbound ACL. So you type in any access list that you apply with the access group command inbound on any interface is processed first because traffic is coming in on that interface. Now if you're going to apply this to a high to low, this could be good for tracking traffic or doing anything like that, like trying to keep count of what's actually flowing through the firewall or something along those lines. But in most cases, this is going to be applied for low to high traffic flows. So from DMZ to inside, or from outside to DMZ, or from outside to inside, something along those lines. Then the second one is going to be the Global ACL. This is also applied inbound and has the deny any logic. The third one is the Outbound ACL, or the outbound application of an access list. So in terms of operation, if you're going to apply an inbound ACL on any interface, you're going to be applying it from the low to high. If the inbound ACL is not applied, then the traffic flows to the Global ACL, which has the deny any logic in it. And if traffic was not already previously solicited, meaning that server 2 came down this direction, came to this guy, went out to here, and pinged my PC at 10.255.10.7. If I didn't initiate that from here, where this is the source and this is the destination, if that is not the traffic flow, then the traffic, but if I tried to ping from this is the source and this is the destination as 172.16.30.10, if this is the destination in a flow like this, actually I should really be changing the color here. Let me switch over to, I'm trying to make the color more appealing for this real quick. So let me go just do this real quick. Because it's like red is bad. Red is deny. So let me go ahead and flip back over to the pen tool. So if I, oops, oh that's something else. So if I go and I say green, if I go from 172.16.30.10 as a source, and I take this path right here out to my PC at 10.255.10.7, then that traffic is going to be permitted because it's a high to low on a 50 to 0 security or a high to a low. That'll be allowed, right? However, if I try to ping, and this is the source and this is the destination, if I reverse the flow and I say that this is the source and this is the destination, going this way here, back up, it's going to get dropped right here. It's going to be from 0 to 50, which is low to high, and this is going to get dropped, if that makes sense. So what's going to end up happening is this is the global ACL taking care of that logic. So I'm sure you guys are picking up what I'm putting down at this point. Now, if you have the third one, which is the outbound direction, the outbound direction is going to say, okay, I have processed the traffic in on an interface, and now I want to determine whether or not, and just to be clear, when you have permitted the traffic in on an interface that was not initiated originally from a higher security level, the inbound ACL is there in case the traffic was initiated from a low security level to a high security level. Then the global ACL is never applied. It basically, it's a bypass check. It says, oh, well, the inbound ACL says it's permitted, so I'm going to ignore it and let it continue on by. If the inbound ACL is not applied from a low to a high security level, the global ACL kicks into play and takes over and says, okay, your traffic is dropped. Now, what about the outbound ACL? The outbound ACL is going to be applied, obviously, outbound with any type of access list that you create. Now, that assumes that you have gotten green check marks from the inbound ACL if it's applied, the global ACL if it has been either configured to be a permit, or the inbound ACL allowed the traffic. And there's one other one that's not listed here. If the high security level to low security level traffic, so from server 2 to my PC, ping, or any other type of situation, if that took over, then there would be a existing connection in the connection table that would allow that traffic to come back inbound. Then the inbound ACL and the global ACL would bypass that. This is for the ACLs come in after the connection table. So think of this as 0.5. The connection table says if there's an existing flow or session in the connection table, go ahead and allow it to come back in. Now, if the connection table permitted it, then the inbound ACL permitted it, and we bypass the global ACL, assuming that it's deny any, and it didn't take into effect because the inbound ACL didn't take effect because the connection table was good to go. Then what's going to end up happening is you're going to have the outbound ACL. Well, if the outbound ACL is a deny at the end, the traffic, regardless if it's from low to high or from high to low, it's going to get dropped. If it's a permit, whether it's a low to high or a high to low, it's going to get permitted. So that's the thing that comes into play here. So let me just recap what I just went through, because I need you guys to be understanding what's going on. If there is a high to low flow, so we'll say that server 2 pinged my PC, then that's going to create a entry in the con table, and the return flow is going to come back in and be permitted without having to check an ACL. Okay? It's going to be allowed to go out, and it's going to be allowed to come back in because it's an entry in the connection table. Now, if I have a situation where the traffic was not originated, or wasn't what they call a solicited or an internally initiated connection, what's going to end up happening is then you have to go through the inbound ACL, global ACL, or the outbound ACL. Now, when I say this is the application of the access list itself, not its actual name or anything else. So with that in mind, This is one of those things that needs to be completely understood. If you are stuck at all on this point, you need to clear that up. Now, we're going to go through examples of how this works as we're going along, but we need to understand how this actually comes into play. Now, what I'm going to go ahead and do to give examples of how this works is we're going to dive into some examples of how this operates, because it's really important that you understand this logic. I'm going to go ahead and I'm going to pull up the console, and I'm going to go ahead and clear the screen. So if you have not already done so, if you're taking notes or you're trying to take screenshots or whatever, go ahead and do that real quick, and then I'm going to go ahead and clear the screen, and we can begin understanding how this actually comes into play. So clearing the screen now. So what we're going to be taking a look at now, and as you can see, there's DMZ, or there's ACL, there's drops here, and this is the global ACL coming into play. It's not, if we do a show run all type include global, there is a global policy, right? It's not until you go onto the ASDM and you go to configuration and you go to firewall and you go to access rules, go ahead and log back in again, that you see the global rule, right? And if you look right here, the global rule is like from any source to any destination. So just like if you were to split this in half here, you'll see it to the left here of my mouse is source criteria, and to the right of it is destination criteria. You'll see that it's a deny IP any. It's an implicit rule. Implicit meaning it's there whether you want it to be there or not. So with all of this understanding in play, we need to, now we can take advantage of, okay, we understand what's going on, so what else do we need to do? Now, what's happening now is I have a couple of ACLs, and I have a ACL applied on the inbound on the outside interface. That's going to allow time exceeded and unreachable messages back in. So if I look at right here and I go to edit, you'll see that I have ICMP time exceeded, and if I go to this one, I have edit, I have unreachable. So if I was to go to the access rules and hit this interface and go edit, let's see here. I don't know what I called it. Is there a sidebar? Oh, no, it's right. I bet it's right. No. But there's edit interface outside. Okay, it doesn't give me the name of the ACL. But if I go to the command line, which is right here, and I do a show access list, I have this thing ACL called ACL trace, and you can see that I have a number of hits on the ACL. If I do a show run access group, it's applied, ACL trace is applied inbound on the outside interface. This allows that communication to come back in. Well, that being said, if I wanted to allow my PC to ping from the outside interface inbound, I would need to allow more than that. So what I'll do is I will come in here and I will type in config t access list ACL trace, and I'll type in extended. Now I can say, before that I can type in line, and I can actually enter a line beforehand. I can type in line 1, because if you look at the flow, it's time exceeded and unreachable. This is processed from line 1 and line 2. If I type in line 1 and I type in permit and I say permit ICMP from any source to any destination, and I hit the enter key, what's going to end up happening is we do a show access list again. We're going to see a line 1 now and then a line 3. It's going to automatically add that, and there's no hits. But if we go back to our console, this guy here, and I hit the up arrow, guess what's happening now? I've explicitly permitted the traffic. Now if I go in here and I do a show access list again, we're going to see 4 hits. That's what you'd expect to see. That's overriding what's happening. So that traffic was not explicitly or requested from the inside. It was originated or initiated from the outside. And this is how that traffic comes through and is able to connect into that particular device. Now I could, if remote desktop was enabled on that particular PC, I could open up an access list and say, okay, I want to connect to this particular device via remote desktop, which remote desktop is enabled. So why don't we go ahead and do that? But here's the thing. When you create an access list, if I was to create another access list called, let's say, ACL remote desktop or something along those lines, and then permit 10.255.10.7 to connect to 172.16.10.30, 30.10 via port 3389, that would allow the connection to come through the firewall and talk to that server, right? And that would pull up and everything would be hunky-dory. What would happen if I tried to ping then? Do you think that would still work? Let's give it a shot. So we're going to type in access list, and we're going to type in ACL, I'll say RDP, and I will say permit, actually this needs to be extended permit, I'm going to say TCP from the host of 10.255.10.7 to the host of, and you can specify any port that you want to, or you can type in 172.16.30.10 equal to, and we're going to say, in this case here, 3389, and hit the enter key. If I do a show access list, I have another ACL called ACL RDP, and it says permit traffic from 10.255.10.7 to 172.16.30.10 via 3389. So I'm going to go ahead and type in access group, and I'll type in ACL RDP. I'll type in inbound on interface outside and hit the enter key. Now, with that being done, do you think I'll still be able to ping my, of course, let's test connectivity first. Let's go ahead and pull up remote desktop. And I'm going to go ahead and say 172.16.30.10. And it's trying. Let's see here. Let's do a show access list. So there was a hit. So we know the configuration is working. This is one of those times where having the log viewer enabled or running would tell us, okay, did we do something incorrectly? So let's look at the log viewer and say, okay, let's try this one more time from a remote desktop connection perspective. We're going to go ahead and hit the connect button again. Bring this down just a little bit over here and say minimize this, and we'll say connect. So you're going to see building inbound connection for connection 3903 from the outside connection to DMZ 3389. So it's trying to build it and it's tearing it, so it's not able to connect, and you can see that. Now you might say, okay, well, why did it fail? Well, there could be a number of reasons why it could have failed. It could be I'm not initiating enough ports or something like that. So we could do this. We can say on the ACL, we can say show access list that we had 2 hits. So instead of we coming in here and having this line, let's say we don't say any specific port numbers, we just simply do this. And we do a show access list. And now we have another entry, but now we're saying entry number 1 is going to get hit first, and then entry number 2 is going to get hit second. So we're opening it up, but in the wrong order. So what I actually need to do is come in here, and this guy here needs to get, I'll need to say no to this access, no to that entry, and then if I do a show access list, now that line is the second line that I added is now there. I'll go ahead and connect, and now it says it's initiating the connection. We'll look at this. It's trying to open it. It's probably has something to do with the fact that there's just not enough bandwidth through the nodes to allow the connection. And we get a failure. Okay, not a big deal. Now the question is, if I was to attempt to go, instead of doing a remote desktop connection, if I was to attempt to try to open up the web browser, because I believe that server is running the web service. Oh, it's not, but I can do that. So let's go to manage. Let's go ahead and add that role real quick. So I'll just run through that process really quick in order to get that to work. We'll say IIS, say add features, next, 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 and install. So we'll give that a couple of minutes to install the process. But you'll notice too that the ping is failing. So what we would need to do is on the ASA, we would need to go ahead and add some entries to this ACL. One of the things you're going to probably want to do is, instead of naming the access list what you want it to be, in terms of what the traffic is going to be, you're going to need to use remarks to help do that. And so what I'm going to do is I'm going to create an access list called access list. The name of it is going to be ACL in from outside. So we know traffic is coming in from the outside, and we can come in here and say extended, and then we can say permit, and I'm going to permit ICMP from the 10.255.0.0/24 mask, I'm sorry, /16 mask, to a destination of any. So, and I said, and I'm going to hit the enter key. So that's going to be one entry. Then my next access list entry is going to be, I want to permit TCP from 10.255.0.0/24, and I want to go to any destination. Now, with this access list configured, I should be able to go to type in access group ACL in from outside. So in interface outside. Okay, so now that I've applied that, I can go show access list. And so now that I've got that access list created, I should be able to go to this guy here and ping it again. And I can. And the question is, will I be able to go to here and do another trace route? If I do a trace route to Google, the trace route is also going to work, because I'm permitting ICMP period back in. And we'll see that looking right here. We have an outbound UDP coming in, and we have an ICMP coming back in. So we see that we're getting some drops, but let's see here. And the reason why we're getting some drops is because the type code is failing. So we're actually going to go ahead and here hit Control C to stop that. But we can go to show access list, and we can say access list and ACL from outside, line 2 extended, permit ICMP from, we'll just grab this line right here. And remember, the ICMP is the source, 10.255. It was allowed from that range, right? But I need to say, actually line 1, ICMP from any source to the destination, to any destination really, as long as, and hit the enter key. Because that's going to say anything. But now if I do that and do another show access list, we're going to see that there's line 1 is now there. So we'll be able to come up there and hit this, trace route out, and so that should be a different experience. But we're also being less specific on our first entry, so traffic should hit that entry now. And it is. If we do a show access list, we're seeing that traffic is hitting this entry now instead of this entry here. Here. So how are we doing on this install? I believe it should be done. And it was successful. So now we have a web server installed. So I'm going to go ahead and Control-C that. But what I'm going to go do is on Firefox, I'm going to pull that guy up because I want to be able to do whatever I want to it. I'm going to come in and type in 172.16.30.10. And if I've done everything correctly, I get an and it's really, really slow. I think that was the problem, is I might have to adjust the remote desktop connection here and type in show options and go resources, experience, and say, okay, so it's set to the lowest settings. Okay, so let's try connecting again to see if that has anything to do with it. And part of the problem might be back on here. Let me go to remote desktop settings and allow remote connections. Okay, so from running, yeah, okay, so it's basically allowing everything. So, and that's not a big deal. But if we go back to, we minimize all this stuff, and we go back to our command line, we hit the up arrow, we're going to see that there are TCP connections coming from 10.255 0.0, and the TCP connections are coming through. And that's exactly what we expect to see. We expect to see that the ACL is working from an inside to the DMZ effectively. And that should be the same thing for going to the inside as well. I had to think about that for a moment. So I should be able to ping from my computer. I should be able to ping 10.100.10.9, and I can. So that means I can ping test 9. So I should be able to go here and type in 10.100.10.9, and I should be able to type in Rob and Cisco and pull up router test 9's web page, and that's working as well. Now let's go back to here. So the ACLs is working, right? Now, just as important as that, we do a show connection long. We should have and what's actually funny is the TCP sessions are being spun up so quickly that by the time I get to this point, they are the connection's closed. So enough information was grafted to close out the TCP session. So if I was to go back to let's minimize this a little bit. If I was to come back to here and go to this guy and resynchronize it and hit the up arrow on here, we're going to see a connection going via port 80. And if I come back to this guy and I hit the resync here and hit the up arrow, we're going to have two of them in here. One to the DMZ. Well, we should. Anyway, let's go show tech support. That's going to take a little bit to run. We should have 3. So one going from my PC to the DMZ server, and from my PC to test 9. And that's exactly what you'd expect to see. So from the inbound interface, I've got one going to the DMZ, one going to the inside, and that's how this is all coming together. This is all 100% inbound ACL. Now, I can go and do the global ACL as well. So I can go and create an ACL and type in access list, I'm having a hard time writing that up. Access list, and we say, we'll say global, even though this naming the ACL global is not applying it at the global level. So we're going to say, there's already a deny there. So what we're going to do is we're going to say, deny, and we'll say IP any. Okay, so, and hit the enter key. Okay, simple as that. And then we're typing access group, and we're going to say global, and we're going to say and apply it to globally. So we'll say global and hit the enter key, and then we're going to do a show access list. So we're going to have a global there now. So if I come back over here and I redo this again, and redo this, and I hit the up arrow, it's not working. As a matter of fact, both of them resynchronized. If I tried to ping 10, it's still working. Why? Because the inside ACL is taking effect. It's bypassing it. So I would have to go into the show run access group. Oop, one too many. I'd have to go in here and say no this access group and do that, and then do a show access list, and then hit the up arrow. No bueno. Not gonna happen. Come over here, resync. Come over here and resync. That's just weird. So it's trying to. You can see it trying to communicate and gain access to it and all that type of stuff. So we're going to go ahead and just close that connection out because it's just going to tie us up. And if we do a show access list, we can see a bunch of hits. So the global ACL is taking effect. And that's why. So now if we go back and we hit the up arrow and apply that, and we try to resync here, and we go to 10.100.10.9, it pulls up no problem. We hit the show access list. We had those entries, show con long, and we have the connection going to the web server. It's open just a little bit longer than the router, but that's okay. And we can probably also ping again. We certainly can. So if the inbound ACL is applied and doing what it's supposed to do, then what should end up happening is the global ACL should never get hit. If the global ACL is applied, but the inbound ACL is not applied, then the global ACL should take effect. So what ends up happening if I go to the global ACL and I say show run access list, you would never do this in production, obviously. We say right here, actually let's do this. No this. Then we do a permit IP any. Oh, yeah, that didn't work. Okay, so that creates, or sorry, I need to do a no in front of this, and pull this back, and then pull the deny out, put the permit in, and then show run access group, no access group ACL in from interface, and then type in access group global and global, and hit the interface. Now with that applied, now do you think I'll be able to communicate still? Let's do a show access list just to make sure the ACLs are still there, and show run access group. The only one that's applied is a global. I can ping 100% because this is an implicit design. And then the web server pops up, no problem. I do show diagnostic log and do a show access list. I'm getting a bunch of hits. Not the ACL, and so the global ACL, if it's a permit and you don't have an inbound ACL, then the global ACL can take advantage of that, and everything will work just fine. Now I can start to selectively drop traffic by putting stuff ahead of the permit IP any or below it, and start blocking it. Now we also have the outbound ACL. So now let's say, for instance, I did not want to allow the web connections from my PC to test 9. So I could type in access list and say ACL out from outside, and say deny TCP extended deny TCP from a source of any source to a destination of 10.100.10.9. I should actually put the host command in there. Go to the end here and hit as long as it's equal to 80. Okay, so show access list, and the ACL is there at the very end. So now we need to type in access group. We'll type in outbound access list ACL out from outside, and we'll say out interface inside VLAN 10. Okay, but it's only going to apply to the to test 9. So now if I go back here and I close this out and I go 10.100 there and hit the enter key, it's being denied. Right? Now I'm just going to go ahead and I'm going to stop it because I don't want to gum this all up. But if I hit the up arrow and I do a show access list, you're actually going to see, if we look at the global ACL, we have a permit IP any, and there's 11. If we look at it before we did that, there were 7 hits. So for every one of the denies here that we got on this guy right here, so we had 1, 2, 3, 4. We have 4 hits on the global ACL dropping the traffic, but we also had a number of, or permitting the traffic through, but the outbound ACL had to be blocked, or the outbound ACL is blocking. But if I go to .10, 10 might not be configured for a let's go to test 10 and show run section HTTP. That would be why. HTTP IP HTTP server, IP HTTP authentication is local, show run section user. Username is Rob, privilege level 15, password is Cisco. So let's try that one more time. Come back over here, we'll go ahead and try that. And it should allow it through. Let's see what it says. Okay, so deny TCP source. So okay, so let's go ahead and take a look at my logic here. So oh, you know why? I know. I'm actually glad this happened. Show run access list. So we look at this access list and it says deny TCP any from the any excuse me, any source to the destination there, but there's no permit statement below that. So I've actually got to come up here and type an access list here and say extended and say permit IP any and hit the enter key, and then do a show access list. So now the permit statement's there. Then we try to go and do this one more time, and there we go. So Rob and Cisco, there we have it. And we hit the up arrow and we show access list. So we look at 29 here. There should be 32 there, and there's hits on the outbound ACL for that. So right now we do a show run access group. We have the global ACL defined, and we have the outbound ACL defined. So let's go ahead and take the ACL in from outside, and we're going to type in access group, and we're going to type in ACL in from outside. We're going to do that, say in interface outside. So we'll do that, and then we will go ahead and we'll leave it alone for there. And then what we're going to do is we're going to go ahead and resync. So that pulled up no problem. This pulls up no problem. And if we go to 10.100.that, that one still gets denied. And that gets denied from the outside ACL, the outbound ACL. But if we go ahead and we can't stop that, and we hit the enter key, the only one that got denied is by the outbound ACL. But if we look back here, we look at 32 on the global ACL, we do a show access list. It's still sitting at 32 from the global ACL. So it was the inbound ACL for TCP connections. This one got hit 21, and before it was still sitting at 15 right here. So now it's 15 right there, and now it's 21 right here. And if we do a show run access group, this one here, I've got them all three applied, and I've just progressively gotten tighter on the number of access groups I've applied, and it just so happens to be it's the access list logic. If you understand that methodology, that will do you a world of good. Now, what we've talked about for the most part here is pretty straightforward stuff. There's nothing terribly complicated about what we're talking about. The global ACL can be a little confusing at times. That's why I spent a little bit of time learning it, and it seems like it's a pretty straightforward logic, and just by playing with the order of operations, you can kind of figure out what the ASA is doing. Now, we're almost an hour in, and I'm glad we covered as much as we did. But one of the things we're going to be doing in the next set of videos, I don't know how many videos I'm going to do yet, is we're going to go and take a look at, we have to go and do objects, object groups, so we can start to pair up connectivity and options and stuff like that, and do things along those lines, and stuff like that. So we're going to be taking a look at how that comes into play as we're going along, and by the time we're all said and done, we're going to have plenty of stuff rolled out to where we're going to have, my goal is to have objects, object groups, which is grouping objects together. There's the service groups, so you can group multiple services together. Then there's the binding those to access lists and stuff like that. Now, mind you, none of these access lists have been configured from the ASDM. I've got a lot more experience on the command line. There's really nothing about this that's much different than the way that the iOS routers work, or iOS switches. So in this case here, most of the logic is pretty straightforward. It's just a matter of going through and knowing what to place where, and you're in pretty good shape. So we'll be taking a look at objects. I'll also be taking a look at time-based access lists and how that comes into play. And there will be some other stuff that I will bring in to it. And you've seen the object rules going back and forth, so you see how that's all coming together. And if we look right here, we see a bunch of entries coming through. So we have, there must be some communication back and forth going on between my PC and, oh, that's, I'm sorry, that's the ASDM, sorry. But that's pretty much where we're at. And then we're going to do, we've verified the interfaces, we've verified the interface ACLs. We know that all that stuff is working as it's expected. Now we need to go into the realm of object groups. And the reason why we need to do that is because if we look at the logic here, this is a little hard to read sometimes. And so it'll make a lot more sense when we start talking about what it is and stuff like that, and how you can start to kind of marry object groups to subnets and stuff like that, and that'll help you understand a lot of the natting that's going to be coming up soon and stuff like that. But access lists are needed, in my opinion, before NAT is enabled. We're going to be getting rid of the routing internally. We're going to do away with all of that and just advertise a default route. Everything's going to point to the ASA, and then we're going to be natting, and then we'll have to do a bunch of NAT. But that's going to be down the road. This will come in handy for everybody, especially when we get into site-to-site VPN and how this all comes into play. So as far as I'm concerned, everything is going well for right now, and stuff like that. So we've got everything dialed in that we need to. So until next time, guys, thanks so much for stopping by, and we'll catch you guys on the next video. Later, guys.